What's happening, guys? Today we're going to be going through how to predict the next best action using TensorFlow 2. Now, what we're going to be doing specifically is going through how to predict the next best activity or action that we should take to progress a sales event. Now, this is a pretty specific use case, but if you think about it, this could potentially be applied across a whole range of use cases. So say we wanted to predict the next thing that's going to happen in a sporting event, or if we wanted to predict something or the next thing that a customer is likely to do. This is pretty useful in terms of where it can be applied. Now, what we're going to be going through is how to actually build this inside of Watson Studio. So we're going to be doing this in Python with pandas, scikit-learn, TensorFlow, and specifically we're going to be using the Keras API. But all in all, we're going to be doing some really cool stuff. So without further ado, let's kick it off. So I'm inside of Watson Studio. Now, first thing that I'm going to do is create a project. So I'm going to create a blank project because I don't need to start with some pre-built stuff. And I'm just going to call it time sequence prediction. You can name it whatever you want. I'm just calling it time sequence prediction, and we'll hit create. Now we're going to be working in Python, as I said. So once that's been created, what we'll do is we'll load up our data and then we'll create a Jupyter notebook. So first things first, let's add our data and we'll hit browse. And I've got an event CSV. Now this is going to be available in a GitHub repo in the description. So don't stress, you'll have access to this as well as the final notebook. So let's just upload that for now. And once that's finished uploading, we'll be able to reference that within our notebook. So then let's grab a notebook and we'll call it sequence prediction. And we'll just change our Python runtime so we've got something a little bit beefier. So let's create our notebook now. Now, if you don't like following along as a video, what I'm also going to make available is the blog post that goes along with this so that you can follow along at your own pace if you're not happy with video. But by all means, you've either got the YouTube data, you'll have the notebook, the data itself, and the blog post to follow along with. Now, the first thing that we're going to do now that we've got our notebook up and running is bring in our data. So the nice thing about Watson Studio is now that we've uploaded it, we can just insert our pandas data frame. So let's bring in our data. Now, what I typically like to do is just rename this to make my life a little bit easier. And we'll bring that in. So, right, so we can see, so we've got some opportunity data. So the first column's got our opportunity identifier, so that's our unique key. We've also got some time data, which is based originally on Excel. We're not really going to be working with that because it's already sorted. We've then also got our stage identifiers. So again, this is it's not really an integer, it's actually a stage identifier. So again, that's a key. And then we've got the action that maps to each one of these stages. So what we want to do first up is, it's good practice, just get a little bit of an understanding on our data. So we're just going to type in df.describe. So we've got about 1,500 observations. This is based on the fact that stage is an integer at the moment, but it's not really all that needed. Let's just check our D types as well. And all right, so opportunities and object, time is float. All right, cool. So the first thing that we're going to do is we're going to create an event key. So this is basically going to allow us to map our stage numbers and our actions together. So it's a little bit more descriptive than what we've got there at the moment. So let's do that first. And we'll create another markdown cell. And we'll just call this data pre-processing. And we'll create, it's good practice to have markdown cells, guys. Just make sure that everyone understands what's happening. So we'll call this import data. All right, and then we'll come back down here. So first things first, we're going to create our event key. So let's just create a new column in our data frame called event key. And we're going to append our stage. Now remember, stage is an integer, so we should transform that. And we're going to append that with our action name. So let's call this action. And we've screwed up something there. And what have we done? So as type int, df stage action. Sorry, we need to convert this to a string. Alrighty, so we've got our event key. Now what we want to do is we want to create a unique list of events. So this will allow us to map our events, which are one hot coded. That's what we'll need to do once we start working with TensorFlow. It'll allow us to map those one hot encoded event predictions back to the text-based event key. So let's quickly do that. So all we need to do is create a list called events, and we're going to grab our unique events from event key, and we just need to call unique, and it's event key. Perfect. So I've got our list of events now. Now what we'll be able to do with that later on is map our one hot encoded events to this. Now we need to add a dummy event at the top, because when we use a specific function later on from Keras called toCategorical, it's actually going to start from 0. So let's append that. We'll just go events equals 0 dash dummy plus events. Alrighty, perfect, cool. So we've now got our events list. Now what we're going to do is we're actually going to create our series of events. So everything that we're going to do based on this is going to be sequence-based prediction. So in order to do that, we need to create sequences of events. Now what we can do is create sequences based on our unique opportunities and the stages that are attached to that. Now, given this is already ordered, we don't need to do a lot of pre-processing, so we can just start creating sequences of events here. Specifically for this example, we're going to use a sequence length of about 5 activities. So if we know that we've got we emailed our client, we emailed them again, we had a meeting, we presented. These 5 is going to represent our series of events that we're going to use to create our prediction. Now, what we're actually then going to do is we're only going to use 4 of those events to predict the next event. So we'll have 4 events, and then we're going to try to predict what the 5th event is likely to be. But first up, we need to create our sets of series. So let's do that. So we're going to create a variable called series length, and we're going to set that equal to 5, and then we'll store. We want to know how many categories we're going to have as well. So this will help us later on when we're reshaping our data set. So not needed right now, but it's useful to have that. And then, as I said, we're going to use sets of series that have 5 events, but we're actually only going to use 4 of those as our X or our input variable, and then we're going to have a separate one as our Y. So in truth, our time steps is actually going to be series length minus 1. So that's eventually going to equal 4, right? Let's just create a markdown cell as well. So we'll call this create series. And we'll run that. Now, what we're going to do to make our lives a little bit easier to create these series is we're going to set our index for our data frame. So we'll call set index. And we're going to set our opportunity column as our index, and we'll set that to in place equals true. Perfect. Let's just check that's worked. Perfect. So our opportunity is our index. This means that we can use the lock function inside of pandas to filter through each one of our indexes, each one of our opportunity IDs. All right, so now what we're going to do is we're going to create an array, so our history array, and our history array is going to store each one of our time series. Now, we're going to need to do 2 loops. So we're going to go for op in df.index, and then we're going to loop through each one of those series. So for x in range len. So we're going to go through each one of our stages dot lock, and we're going to filter through specifically on our current opportunity, and we're going to go through each one of those values, and then we're going to subtract, or we're going to do it based on our series length. So that's going to make sure that we have full sets of series within our data. Then what we're going to do is we're going to append each one of those sets we're going to append the values. And what we're going to do is we're going to start wherever our current counter is, and we're going to add however many our series length is. So that should be about right. Let's take a look. Alrighty, what's happened there? So range, len df stage. Oh, we've forgotten that. And we need to remove that as well. There we go. So let's take a look at our history. Perfect. So we've got sets of 5 events. So we can see here that it was event 1, 1, 2, 3, 3, 1, 2, 3, 3, 3, 1, 2, 2, 3. So you can see we've got sets of 5 events. Now we should probably take a look at that shape. So let's just have a look. We can use the NumPy function. Have we imported NumPy? We haven't yet. So let's do that. Probably import TensorFlow as well while we're at it. Alrighty, so we've got, what is that? 16,176 examples, and we've got 5 steps in each one of those examples. So now what we're going to do is we're going to one-hot encode this. So right now, if we take a look at our data set, these, whilst they represent, or whilst they're numbers, they don't actually represent our one-hot encoded variables. So this isn't really going to work when we actually try to pass this through to TensorFlow. So what we want to do is we want to represent this as a one-hot encoded vector. So we can do this pretty easily just using the toCategorical function from Keras. So if you want to learn a little bit more about that, we can go to categorical, and it's here. So there's a whole bunch of documentation on how to use this, but I'll show you how to use it now. So let's bring it in. So we're going to bring it in from Keras, utilities, import to categorical. And then what we're going to do, so we're going to create our X variable now. So we're going to say empire. So we're going to convert it into a NumPy array first up. And we are going to iterate through each one of our rows. So remember, we only want 4 time series per observation, right? So what we're going to do is we're going to go row and then time steps. So that's going to bring in the first 4 observations out of every time series that we've got in our history array. For row in history. How does that look? Nope, we haven't closed that. It's a bit better, and remove that. That should work. What do we call it? Time step. Perfect. So we've got sets of 4, and now we're going to do the same. Or we'll one-hot encode this first. Perfect. So you can see that we've now got one-hot encoded representations of our data set. So if we take a look and we call this shape. So you can see we've actually now got our one-hot coded array. So we've got 4 time steps and we've got 12 features. So that basically maps through to each one of our events that we had up here. Right, yeah. Now we'll do the same for our y, so our target variable. So we're just going to convert it to a NumPy array first up. And then this time, rather than taking a series, we're actually just going to take the last event. So let's do that. So we're going to go row, time, step, for row in history. That looks about right. Now remember, fourth is going to represent the fifth observation because the arrays start from 0 in Python. So that looks fine. Let's take a look. Right, and we'll just check the shape. Perfect. All right, so we've got 16,176 observations, and then we don't have a separate array because they're all just currently stored in a single array. So we'll need to work on that a little bit. So first up, we're going to convert that to categorical. Y equals to categorical, and then we will pass through our y variable, and then we'll reshape it to something that's going to work for us. So we're going to convert that to 1, and we'll convert it to the number of categories that we've got. That should work. Let's take a look. There we go. Alrighty, so now we've got 16,176 observations, and each one of those contains our 12 features. So let's take a look, and you can see here that our y basically represents our fifth observation in each time step, but it's a one hot coded array, which we can now work with in TensorFlow. So this should be good to go. Awesome. Alrighty, now what we're going to get to do is, again, good data science practice. Remember, we're following CRISP-DM here, so we're going to create our training and our testing data set. So let's set that up. So we can use scikit-learn for that. And we're going to import that from scikit-learn. Model selection, still my favorite library of all time. We're going to import train test split. And then we're going to create our xtrain, xtest, ytrain, and sorry, force a habit, I'm a little dyslexic. Train. And then we're going to pass through our x, our y, our test size. I'm going to set it to 30%. By all means, do whatever you want, but I've found 30% seems to work pretty well. And let's just check the shape of all of those. Perfect. All right, so we've got slightly lower xtrain, higher xtrain, lower. Yeah, that looks fine. All right, now we're going to get into the fun bit. So so far we've imported our data, we've done a bunch of our pre-processing, we've created our series, we've split our data into train and test. Now the fun bit, actually getting onto the modeling. So specifically for this modeling, we're going to be using the Keras API out of TensorFlow 2. And we're going to be using a LSTM model. So if you're not familiar with LSTM models, I highly recommend Andrew Ng's Coursera course on sequence-based deep learning. I'm going to skip over the fundamentals and just get right into it. So we are going to import what are we importing? The models API from TensorFlow and specifically from Keras. And we are going to import the sequential API, and then we're going to import 2 layers. So we're going to import the LSTM layer and a dense layer, so aka the fully connected layer. Keras.layers, import LSTM and dense. Cool. All right. Now what we're going to do is we're going to create a instance. So we're going to create an instance of the sequential model. So let's call it model equals sequential. Boom, and your model's built. Now, I kid, we're going to add some layers. So let's add our first LSTM layer. And we're going to set it to 10 units. Activation of ReLU. And we're only going to make it 1 layer for now. So we don't need return sequences, but what we do need is our input shape. Now, remember, we went to a whole heap of effort to shape our array into a specific reason. And we actually created some variables up here. So series length, categories, and time step. Now, you're going to see why, because this is going to make it a whole lot easier to understand what's being passed to our LSTM model. So the shape that we need is based on time steps. And remember, this is our input time step. So it's going to be 4 by the number of categories, which is 12. Right, so if we take a look at our time step, that's 4, and our categories, that shape is 12. Now, if we take a look at our xtrain shape, you can see that it's 4 and 12. So our series is already shaped in a way that's going to be accepted by our LSTM layer. Alrighty, but now what we want to do is we want to reduce these results to just the 12 categories. So what we're going to do is we're going to return back only our 12 categories, and we're going to get a binary result, a 1 or 0. To do that, or actually we're going to get a probability, which we're then going to use the argmax function to return our result. So we'll add another layer, and this is where the dense layer comes in, because it'll allow us to convert our sequences that we get from our LSTM model to basically a sequence of binary results, 1 or 0. And specifically for that, we're going to use our softmax function. So let's create a dense layer, and we're going to set this to the number of categories that we want returned. Right, so we can just use our categories variable, and then we're going to use a softmax activation. Boom. Right, yep. Now, last thing that we need to do is compile our model. So we'll type in model.compile, and we're going to use the atom optimizer, and we're going to set our loss equal to categorical cross entropy. Perfect, and I think that should be good. Got an error there. Sorry, this should be input shape. Perfect. Now, always good practice to check what our model looks like. So if we go model.summary, you can see we've got our first LSTM model, and then we've got our dense layer, which is going to return binary or our softmax predictions or probabilities in the shape of 12 individual arrays or 12 individual values. Cool, I think that's good. We're ready to fit our model. So let's call model.fit, and we're going to fit it on our train data set. And let's just run it for 1 epoch for now, just to make sure it works. And that's looking fine. So what you're hoping to see is that loss reduces with every training step or every batch. So what we'll do is we can crank that up a little bit now. So we've only done it for 1 epoch, so let's crank that up and let it run for 10 epochs. So this shouldn't take too long depending on what machine you're training on. So if you're using GPUs, this stuff is obviously going to train a heap faster. So I'm just running on CPUs for now. No worries if you don't have GPUs available, it'll still run. Now let's let that finish. And then what we're going to do next is generate some predictions based on our sequence model. Look, 5 epochs should be enough, so we can stop that now. Alrighty, now what we're going to do is we are going to generate some predictions, and then we'll take a look at what our accuracy looks like. So let's create another markdown cell. Again, force a habit, guys. I like creating documentation as I go. Predictions. And then what we're going to do is we're going to predict based on our test set. So we can say, we'll create a new variable called predictions, model.predict, and we'll call x test. Awesome, got our predictions. Now let's take a look at one of our first predictions. So if we go events, actually we won't do that just yet. We'll take a look at prediction 1. We've called it predictions. You can see we're getting probabilities returned. Now what we can do is just take the highest one. So we can use the argmax function. and we're getting 6 return. Now we can map this back to our events list. Remember, we spent all that time creating this events list here. This basically allows us to quickly map back to that over here. Yep, that should work. And what have we done there? Nope, that should be square brackets. Cool. And we can see that our prediction is that the next thing that we should do is provide some pre-sales support. Now, if we take a look at what the actual event was, we can go to our Y test one, and let's map that back as well. Cool. Can see that we probably should have prepared a POC, but I mean, you can tell it's actually generating predictions. What about for 0? 11, we're not actually getting great results. Maybe we should train a little bit longer. About 15. All right, so 15 is predicted correctly. Let's actually evaluate our accuracy, because maybe we might see some slightly different results. All right, and then we're going to import some evaluation metrics. So we're going to use top K categorical accuracy. So if you want more on metrics that you can use, there's a whole bunch on the Keras documentation. We're going to import that. And top K categorical accuracy will allow us to evaluate how well the top predictions compare to the actual prediction. So that's why it works really, really well with multi-class classification. So we're going to say with TF sessions, we'll create a new session so we can evaluate. Let's print it with a few different results. So top K categorical accuracy, Y test, and our predictions. We'll set K equal to 1. So this will evaluate our top prediction versus the actual result. Let's do a few of those. K equals 2, K equals 3. And that should work. All right, so we can see about 53% of the time we're getting the right result if we just take our top next event. 89% of the time if we take our top 2 events, and 98.5% of the time if we take our top 3 events. So what you might end up doing is going, hey, these are probably the next best 3 actions that you should potentially take to help our customer. And more often than not, you're probably going to get that right. So overall, what we've gone through today is how to take our sequence data, how to shape that into the correct shape to pass to our LSTM model, and then eventually we're generating our next best action in order to predict what we should be doing for our particular client. Now, as I mentioned before, I'm going to post a link to the GitHub repo that contains the data set for this, as well as a fully worked notebook. There'll also be a blog post to come, so you should be able to get onto that as well. Hopefully, if you like this tutorial, be sure to like, share, and subscribe it. It'll mean a heap to me. Thanks so much, guys. Enjoy your day.